Good morning, one and all. Today I am here to talk about oxyacetylene gas welding, which is one among the most used welding procedure in the category of gas welding. Now let's discuss the basics of gas welding. So gas welding is a type of fusion welding, that is, gases such as oxygen, acetylene, etc. are used. They are allowed to combust together, and as we all know, combustion is the process of the fusion between fuel gas and the oxygen, or the reaction between the fuel gas and the oxygen. As a result of combustion, a large amount of heat is produced along with water and carbon dioxide. This heat is used to melt the parent metal, and further it allows in the joining of the metals. Here we can use different filler materials in order to reduce the formation of pores. So as we all know, these pores are one among the weld defects, so we can use filler materials in order to reduce the pore formation. So these are the types of gas welding. We have different types of gas welding, such as oxygen acetylene, oxygen hydrogen, air and acetylene, butane or propane welding, MAPP gas welding, that is methyl acetylene, propadiene petroleum gas welding. From the name itself, we can understand what are the gases that they are using in the welding process. In oxyacetylene, they are using oxygen and acetylene. In oxyhydrogen, they are using oxygen and hydrogen. So such like that way. Oxyacetylene gas welding. This type of welding is developed by the French engineers Edmond Fouché and Charles Picard in the year 1903. So the heat is obtained from the combustion of fuel gases, that is oxygen and acetylene. During the combustion of oxygen and acetylene, a large amount of heat is produced. Thus, this heat is used to melt the metals, and then in turn a weld is formed. So this is the basic concept of oxyacetylene gas welding or any type of gas welding. Next we have the instrumentation of oxyacetylene gas welding. First we have oxygen cylinders. That is, oxygen cylinders provide oxygen for the welding process, and they are painted in black in order to identify easily. And usually the size of oxygen cylinders are 3400, 5200 and 6800 liters, etc. And their pressure is maintained at a typical range, and it is mentioned there. Then we have acetylene cylinder, and it is painted in maroon. So oxygen cylinders in black and acetylene cylinder in maroon, so that we can identify them easily. And other difference is that here the valves are screwed left-handed, and in the case of oxygen cylinders they are screwed right-handed. And the size of acetylene cylinders are 2800 to 5600 liters, and the pressure is also given, that is 1600 to 2100 kilonewton per meter square. And next we have pressure regulators. That is, pressure regulators, from the name itself we can understand that it is to regulate the pressure of oxygen and acetylene, because the pressure has to be regulated, otherwise it leads to the formation of various weld defects and other disasters. And the value of the pressure that we are going to supply, it depends upon the diameter of outlet nozzle and supply flow rate of gas. Then we have pressure gauges. It measures the pressure with respect to the atmospheric pressure, and also two pressure gauges are mounted on each of the cylinders, that is, two separate pressure gauges. and one is used to understand the pressure of gas inside the cylinder, and the second gauge is used to understand the supply pressure of the gas. And then we have welding torch or blowpipe. It is used for moving or transmitting oxygen and acetylene in the required volume, and also it helps in the ignition. And two types of welding torch are used, that is high pressure type and low pressure type. According to the application, we can select the type of welding torch. And then we have hose and hose fittings. It is used to carry gases from respective cylinders, that is we have two cylinders to use to carry the gas from respective cylinders to welding torch. And the materials used to construct these are rubber and fabric. They are painted in black or green for oxygen, and red or maroon for acetylene. Here we have a schematic representation of OXY-ACETYLENE welding. First we can see that the combustion of fuel gases happens, that is the combustion of oxygen and acetylene gas. Then it leads to the production of a large amount of heat, and this leads to the melting of surfaces to be joined, that is it leads to the melting of parent metals. Then the molten metals flow together. After cooling, it leads to the formation of continuous solid weld. So this is the flow diagram of oxyacetylene welding. You can see acetylene gas cylinder, oxygen gas cylinder here. You can see the pressure regulators here, and that is it. It is here to control the pressure of both the cylinders. Then we can see the connection between these cylinders and the torch. That is, the torch ignites the flame, and then we can see the base metal filler rod is there. So these are the applications of oxyacetylene welding. For joining thin metals, this type of welding is used, and for joining materials in case high temperature of rapid heating. Then in automotive and aircraft industries, in sheet metal fabrication plants, and also for joining most ferrous and non-ferrous metals, that is carbon steels, aluminum, magnesium, copper, etc. This type of welding is used. And thank you all for watching.